Hi everyone, distance learning assignment number 10, Mrs. Ludwig here. Hope you're having an okay day. So today is another day on finding the domain and range of graphs. And today we're going to deal with arrows on the graphs. So fun. Okay, so first thing I just want to remind you, domain, abbreviated dx, are the x values. And the x values go left to right. Okay, let's just do that. And the range, which is abbreviated RY, are the y values, and those go down to up. Okay, so there's a nice little note. So for number 7, we're starting at number 7 because I split the lesson into 2 parts. So you did the previous lesson in assignment number 9, the first part of the lesson in assignment number 9, and then assignment 10 is the second part. Okay, so domain goes left to right. So the leftmost part of this graph is an arrow. Now I know some of you are thinking, yeah, but the leftmost point is -5, but there's an arrow there. The arrow means it's just going to the left, to the left, to the left. So remember, if you see an arrow at the left-hand side, that's negative infinity. And then look at the rightmost point. The rightmost point, again, it's at 5, but there's an arrow there. So that means it's just going and going and going and going. So that means that's positive infinity. So that is your interval notation with the brackets, the parentheses, the infinities. And the set notation is all real numbers, that fancy R. And yes, I hear you guys asking, can't we just write a regular R? Absolutely. I just like the fancy one. It's fun to be fancy every once in a while. Okay, so now for the range, the lowest point to the highest point. So the lowest point on this curvy curve is at -4, and it's a solid line. So that means I'm going to have a bracket -4, and then the highest point of the graph is not here. It's this one. It's this arrow. Again, that is at 4, right? But because it's an arrow, it just keeps going, 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 up, 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 which means that's also infinity. Infinities always get parentheses. That was your interval notation. So the lowest was -4, the highest was an arrow, which means infinity. So for set notation, you do squiggly bracket y, line y. Y is an element such that the y values are greater or equal to -4. Okay, so with the set notation, you're going to have a y and a number, and then you have to figure out, is it going to be greater than, equal to, less than, equal to. And unfortunately, there's no set way of doing this. Like last time, there was a beginning and an end. So all the answers looked the same pretty much. These are not always going to have one look to them. And you'll see what I'm talking about when we go to number 8. So for number 8, if you notice, it only has one arrow. 7 had arrows on both sides. This one only has one arrow. So what I'm talking about is the following. Why don't we do set notation? Actually, I like interval notation first. Interval, int, set notation. Okay, so domain. I always like to do domain first, the left to right. The leftmost point is here, and that's at the x value of -4. And it has a closed circle, so it's -4, comma, follow the behavior of the graph. There's an arrow. Now, I know you guys are saying, but the graph ends at 5. I know, but there's an arrow there, and it's just going, 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 all the way to the right indefinitely. So that means that would be infinity. So now the set notation's with the squigglies, X line. All right, your reference point is -4. So X and -4, and think about it, the X values are getting bigger than -4. So this one would be greater than equal to, and I'm putting equal to because it's a closed circle. Okay, so now the range, the lowest point of this graph in a couple of places is -2. So that's my lowest, and it's a solid curve and a closed circle, so it's going to be bracket. And then the highest point appears to be here, right, at 2. But there's an arrow at 2, which means it keeps going, 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 going all the way up. So not only is it going all the way right, it's going right and up. So that means that's also infinity. So for my set notation, I have the y values are getting greater than or equal to -2. Okay. So it's the same idea where there's arrows on the graph, but sometimes you have 2 arrows. This one you have 1 arrow going on the right. Look at number 9. You have 1 arrow going to the left. So let's keep doing. We have your domain in interval notation to be, okay, the leftmost point is an arrow. That means it's -infinity. And the rightmost point is here at x is 0. Remember, this is the coordinate 0, 4. So the x value is 0 with an open circle, so that's parentheses. Now your set notation, think about it, you have, like we've been doing, when you have a number with infinity, you have in set notation y in the number. You have a number with infinity, you have the variable and the number. See what I'm talking about? So here we have infinity with a number. So for set notation, I'm putting the variable because it's x, because it's domain, I'm using x, and the number we established it was at was 0. Now we have to figure out, are the x values getting bigger or smaller from this point? Well, they're going to the left, so that means that they're less than, and I'm not putting the line because it's an open circle. So it's just less than, it is not equal to. All right, your range. Interval notation is always the better one to understand, so we're always going to start with interval notation. The lowest point is an arrow. It's at -5, but it's an arrow. So if it just keeps going, 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 that means that it's at -infinity. And the highest point, now hear me out, the coordinate we all agreed was 0, 4. The highest point is 4 at an open circle, so it's parentheses. Okay? It's really a good idea to identify the coordinate when it's on an axis because it's just making life clearer. So then the set notation, set always gets the squigglies, and I'm dealing with range. So here's the pattern that's continuing. I have a -infinity and a number, so for set notation, I put the variable, its range, so I'm putting y, and the number, but now I have to figure out, are the y values bigger or smaller than 4? So think about it. I'm here at 4, and the arrow is going down. So that means my values are getting smaller, which means less than. And it's an open circle, so it's less than. All right, so hopefully you're starting to see the pattern that if your interval notation has a number and an infinity, your set notation will have a variable and a number, and then some sort of inequality sign, depending on the behavior of the graph. Okay, so now we're back to 2 arrows, but look at this one. This one is going upside down where this one went up. So we've done all possibilities. Look at us. All right, so interval notation. Domain, dx. What is happening from left to right? All right, the leftmost point is here at -4, but it's an arrow. So if you have arrows, that means infinity. And why am I putting a negative infinity? Because it's in the negatives area, right? And then it goes up, and then it comes back down. So the rightmost point is another arrow. Yes, I know it's at 5, but it's an arrow at 5, so that means it keeps going. Positive infinity. Infinity always gets parentheses. Has anyone been thinking to themselves, does the order matter? Yes, order matters. Check it out. The small number goes on the left, the big number goes on the right. Small number on the left, big number on the right. Small, big, left, right. Small, big, small, big, small, big. I'd say half the time it's a negative number on the left and a positive number on the right, but that can change, and you'll see that it will change. So then don't forget set notation, infinite is the R. I like to make a fancy one. Now your range, what's your lowest to your highest point? All right, so we have two low points here and they're both arrows. So that means it's negative infinity. Your lowest point, is negative infinity. And your highest point is here at 3, right? Because that's your x value, that's your y value. And you're going to put a bracket there because it's a closed circle. Okay, so now check it out. You have a negative infinity and a number. That means your set notation is going to have a y because we're dealing with range and the number 3. And now you have to figure out, will the inequality be a less than equal to, a greater than equal to? And I'm saying equal to because it's a closed circle. So think about it. At the y value of 3, the graph is going down, right? The arrows are pointing down, which means the numbers are getting smaller than 3. The y numbers are definitely getting smaller. So that's why I'm going to put less than equal to. All right, so compare with number 7, where the arrows were going up, our range was greater than equal to. Notice here the arrows are going down, it's less than equal to. All right, so hopefully this is starting to make a little sense, hopefully. It's a very complex topic, not ideal to be learning this distance, long distance wise. Okay, so now let's go on to number 11. So 11 is another graph where there's one arrow. So let's do interval notation first, set notation second, domain, range. Okay, interval notation. Domain. Domain goes left to right. So my leftmost point is at -5, but it's an arrow. So that means it's negative infinity. My rightmost point is 4. And don't forget, writing the coordinate is very helpful. So this coordinate is 4, 0, and it's a closed circle. So your rightmost point is the number 4, and that gets a bracket because it was a closed circle. Bracket means equal to. Infinities always get parentheses. Okay, so then set notation. Don't forget, if you have an infinity, a positive or a negative infinity, and a number, your set notation is always going to be x or y and then the number. So now we have to figure this out. Here's the arrow, and here's the number. If you guys would notice, here's your 4, and then the values are getting smaller, right? All the x's are getting smaller. So that means less than equal to. Has anyone made the connection yet that if you're dealing with the domain and set notation, your inequality sign follows the direction of your arrow? Have you noticed that yet? So check out number 9. Well, like 10 doesn't apply because there were 2 arrows. I'm talking about 1 arrow. When there's 1 arrow on the graph, see how the arrow is going this way? Your domain went that way as well. See what I'm talking about? It went less than and it's following the direction. This one doesn't count because there's arrows on both sides. I'm talking about when there's 1 arrow. So look at number 8. For the x's, notice how we chose it to be greater than equal to because the x values were going greater than. The arrow is going that way. See that? I'm talking about the x's only right now. Okay. So for the range is the y values, the lowest point to the highest point. The lowest point of the graph is here, and it's not 4, it's 0, remember, because that coordinate is 4, 0. And it's a closed circle. And then the highest point is here, which is an arrow. So I know it looks like it's getting flat, but it actually, the behavior is it's going like this. So it is increasing, it's getting higher. So that means your highest point is infinity. If ever you see an arrow for the highest point, it's infinity. Arrows mean infinity. Okay, so again, we have a number and an infinity. So my set notation is going to be set up such that I'm dealing with range. So I'm dealing with y, and then the number. Now we have to figure it out. Here's the number. The graph is going above it, right? So obviously, as you can see, the y values are getting bigger. So that means I'm going to put greater than and I'm going to put equal to because it's a closed circle. Okay, and then the last one, okay, so that was another one where it was just 1 arrow. The last one's just a little review, meaning there's no arrows. This was from assignment 9. Where there's a beginning and an end point. I just wanted to show you the difference between the two. So the domain has a beginning and an ending, right? We'll do interval notation first. So the domain is the x's. The leftmost point, x is left and right, is -5. And the rightmost point is here at -2. And they're both open circles, so you put parentheses. Do you see the difference from literally every other question we did today? When there's arrows, there's infinities. When there's a beginning and an end, you have parentheses and brackets. So for set notation, this is the kind where you put x in the middle and the small number on the left, the big number on the right, and then both arrows always go that direction. Are you remembering like now you see the difference of what we were doing? So both arrows point that way no matter what when it has a beginning and an end. So then the range, the lowest part of this graph is right here at the y value of -4. So that's -4 with a parenthesis because it's an open circle. And the highest number on the graph, the highest point is at 4, right? And that also gets a parenthesis because it's an open circle. So then the set notation is such that the variable goes in the middle, the leftmost point, or no, I'm lying, excuse me. The lowest point goes here, and the highest point goes here, or you just put the small number, big number, small number, big number. And always, both signs go that way. You just have to figure out if they have the line underneath, and this one does not because they're open circles. All right? So this example was to show you what you started with and how it's super different from when you have 1 arrow. Arrows will make infinity come into your answer. So 1 arrow looks like this, and 2 arrows looks like this, where you have -infinity to infinity and like a beginning and an ending with infinities. Okay, so what should you take away from this lesson? If you see an arrow in the graph, you will have an infinity in your answer somewhere. Okay? If you don't have arrows in your graph, there's a beginning and an end, and your answer will look like that. All right. This is a lot to take in. Try the homework. Please email me and Miss Mulligan or message me and Miss Mulligan if you need to talk them out. We are more than willing to give you a call and miss you, and I hope that today is okay. All right, guys. Keep up the good work. Bye.